Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers and subscribers. Here is another problem traces for you to master. Determine the force in members EI, GH, and JK. Also identify zero force members. So here is the truss, and it is a K-truss actually. I hope that you're already familiar with the manner this truss is being analyzed, and I hope that you will charge it from your experience. So first, I need to solve for GJ. We begin by solving GJ. So I introduce this sectioning and later this sectioning here to solve for DG, which is important in preparation for solving for GE, which in turn can be shown to be the negative of the force of EI. Then from there, we can solve for EI. Then we go back to joint G, isolate it as a free body diagram to solve for the force of GH, which is also required by summing up forces horizontal. Then, in the later part, we solve for the reactions at J, horizontal and vertical. The horizontal is obviously 30 kilonewtons leftward. Then the vertical component will be obtained by summing up moments about K. Then the final part would be to sum up forces vertical to solve for the force of Hj, then summation forces horizontal to finally solve for Jk. So that's the flow of the planned solution to this problem. So first, I consider this sectioning and the forces above that section. So the forces involved are the following as shown in the figure, and this is SGJ. But first, let's have zero force members. These two members are zero force members, BC and CF, because uh, there are only two forces, concurrent forces at C in equilibrium, and therefore, by principle, these are zero force members. You may prove this. We may prove this by summing up forces horizontal. Then this is C0, summation forces vertical. If BC is 0, then CF is also 0. So considering forces above, we sum up moments about I equals 0, counterclockwise positive. This is SGJ. So SGJ times 4, then this 10 kilonewton passes through I, so it has no moment. So this is clockwise, so equals 10 times 3 plus 10 times 6. Then from there, we can solve for SGJ, and it is equal to 22.5 kilonewtons. It is tension. So next, we section this part here. And these are the forces involved to solve for SDG. So we sum up moments about F equals 0. This is SDG. So counterclockwise positive, SDG times 4. Then this is the only force that has moment about F, so equals 10 times 3. So SDG times 4 equals 10 times 3. From there, we can solve for SDG, which is also tension, and it is 7.5 kilonewtons. Then having found SDG, next is to solve for SGE by considering this sectioning here, CC, and we consider forces above C, and for you to clearly see the free body diagram and the forces involved, let's have another figure here, and let's put the unknowns as well as the knowns. SDG is 7.5. This is SEG, this one. and this is SEI, which is required eye colored into yellow, and the slope of SEG is 2 meters horizontal because that's 2 meters, 3 meters vertical. Therefore, the length is square root of 13. So I apply principle of transmissibility of a force. Let's move SEG at G, which is here, and we sum up moments about I, the intersection of SEI and this unknown member force, which is FI, as shown. That's 3 meters also. And this is G. SEG has two components, horizontal and vertical, but the horizontal component of SEG passes through I, so that's why I just labeled it with, or denote it with dashed component. This is the important component of SEG by principle of transmissibility of a force. This is equal to SEG times 3 meters over square root of 13, where square root of 13 meters is square root of 2 square plus 3 square. So we sum up moments about I to solve for SEG, counterclockwise positive. So SEG times 3 square root of 13 times 4, here the solution, plus 7.5 times 4, then equals 10 times 3 plus 10 times 6, equals 10 times 3 plus 10 times 6. So solving for SEG, SEG is equal to 5 square root of 13 kilonewtons. We then isolate joint E to relate SEG with SEI. These are the other two additional forces at E, but they are not important because we sum up forces vertical equals 0. The slope of the vertical component of SEG is SEG times 3 square root of 13. The vertical component of SEI is SEI times 3 over square root of 13 also. So summation forces Y equals 0. SEG times 3 over square root of 13 plus SEI times 3 over square root of 13 equals 0 at joint E. So 3 square root of 13 will be cancelled. Then we say that SEG is the negative of SEI, or SEI is the negative of SEG. Since SEG is 5 square root of 13, let's now express that in decimal. So SEI is negative 5 square root of 13, or negative 18.03 kilonewtons. So it is negative. It means that SEI is a compression member. So that's the answer to SEI. So we consider isolate joint G this time, and remember that SEG is 5 square root of 13, and the slope of SEG is 3 vertical to horizontal hypotenuse square root of 13 as shown. Summation forces horizontal, we can now find SGH. So summation forces or X equals 0, SGH plus 10 kilonewtons plus 5 square root of 13, the horizontal component is multiplied by 2 square root of 13. So plus 10 plus quantity 5 square root of 13 times 2 over square root of 13, the horizontal component of SEG, then equals 0. SGH, therefore, we can cancel that, is 10 plus 10, 20 to the right, so negative 20. So SGH is a compression. Member GH is a compression member also. So it has a magnitude of 20 kilonewtons. So it is compression. So to validate these answers, we check the equilibrium of joint G by summing up forces vertical, so that these forces are involved, the calculated values here. So summation forces Y equals 0. Then we have 5 square root of 13 times 3 over square root of 13, the vertical component of SEG, plus 7.5, then minus 22.5. Then minus 22.5. So this cancels. So 5 times 3 is 15, plus 7.5 is 22.5, minus 22.5. So summation forces Y is indeed 0. So that means we are sure that these answers are correct. Then we consider the entire system. We put the reactions at J, horizontally 30 kilonewtons, vertically, let's call that JY, and let's anticipate that it is downward, and R sub K is upward. That's 30 kilonewtons, summing up forces horizontal, obviously. And this is R sub K. So summation of moments about K equals 0, considering the entire system. Don't mind this section here. We are not revealing them. So we consider this entire system. Summation moment about K equals 0. Counterclockwise positive, so JY times 4. Then this passes through K, so it is not involved. Then equals 10 times 3 plus 10 times 6 plus 10 times 9 equals 10 times 3 plus 10 times 6 plus 10 times 9. Solving for JY is 45 kilonewtons downward. So we then isolate joint J, draw the free body diagram. We have SGJ upward, which is equal to 22.5 kilonewtons. The JY is 45 kilonewtons. This is SJK. Let's draw it. So that's 22 kilonewtons. This is SGH. The slope is again 2 horizontal, 3 vertical, and this is the required GJ. So to solve for SGJ, we solve for SHJ first by summing up forces vertical at joint J. So SHJ times 3 over square root of 13, the vertical component of SHJ, plus 22.5, then equals 45. SHJ therefore can now be solved. It is equal to 27.04 kilonewtons. Then finally, summation forces horizontal equals 0. SGK plus the horizontal component of SHJ, which is 27.04, times 2 over square root of 13. So SGK plus 27.04 times 2 over square root of 13, then equals 30 kilonewtons leftward. So from there, we can solve for SGK, and it is equal to 15 kilonewtons. So it is positive, so it is tension. So that's it, and I hope that you were able to follow the solutions and explanations. And by the way, I forgot to mention that if you want to solve this by your own, you may pause the video at the start, then try to compare answers later.